All right. Good morning, everybody. Welcome to the final working group meeting for August, right before the long weekend. Uh, so I don't have any new members on the agenda for today. Is there anybody who hasn't had the chance to introduce themselves that would like to? No? All right. Well, quick and easy. In that case, we'll head straight over into our presentation. So today we have Kate Barisic, Hassan Ahmad, Ryden Chalmers, and Thomas McClay from Haggerty, and they'll be giving a bit of an overview of their how their season went this year. So go ahead, Haggerty.
All right, thank you. Let me just share my screen. This one. All right, can you see that full screen?
Yes, we can.
Perfect. Okay, so yes, we are the Haggerty Summer team. We are going to do a presentation about the projects we've been working on and what we've been up
All
to
right. Take
this
care.
summer.
Bye-bye.
Sorry.
So this is just an overview of who's going to be speaking today. Myself, I'm Kate, and then I'll be followed by Thomas, Hassan, and Ryden, and we will all be introducing ourselves later on in the presentation. So my name is Kate Barisic. I am the digital media specialist at Haggerty AgRobotics. I've been in this position officially for about 4 years now, and unofficially for a couple years prior to that. Um, I go to school at Sheridan College in Oakville. I've done some general visual arts, and then I'm also doing my Bachelor of Illustration currently. I often get quite a few weird looks when I say that I'm in art school, but I'm working for Haggerty AgRobotics. But I do come from a strong farming background, so my whole family farms. I farm with them. I work in part for Haggerty Creek. I do custom applications of fertilizer um, in the spring and later in the summer. So one of the main parts of my job is I run all of our social media, as well as manage what the techs put out on their social media account. So this is the obligatory, if you want to see what we're up to, here we are on all of our things. Give us a follow. We do some cool stuff. Um, so I post about twice a week from each account. And I do like event updates, pictures and videos of what we've been doing, all that sort of stuff. Also with this, as I just mentioned, I do a lot of advertising. So for the company, I do all of our demo flyers as well as advertise upcoming events that we might be at, as well as make promotional materials that we give out at events, like sell sheets as you see on the side there. So one of these posters could take anywhere from 1 hour to 8 or 9 hours. It just depends. I might go through 10 to 12 iterations of each one before I have one that I'm happy with. So it takes quite a while to do that. I'm a bit of a perfectionist in that way. I also do the website, so I'm in charge of keeping it up to date, putting new stuff on there, switching out information that might be out of date, as well as looking at all of our analytics to see what pages are getting the most views and working to make sure that all the content on our site is accessible and able to be seen both from desktop and mobile. Hand in hand with all those things is I do a lot of photos and photo editing. Um, I try really hard to make sure that all of the photos that we put out as a company are our own. Um, and so this is just a glimpse of what it looks like when I'm editing a photo. And as well as on the side, there's some like before and afters of how I color correct and fix lighting in images. One of the biggest projects that I've been working on this year is a robot catalog. So similar to the cell sheets that I showed earlier, this will be a multi-page booklet with further text and information about all of the robots together. So this is a screenshot of Adobe InDesign. So it's a very good graphic design software, and this is what I work in for most of my posters and other graphic things. This summer, I've also had the chance to work on a couple other projects. So we've been working on filming some robot FAQ videos to put out on our social media and website to help teach people who have the robots how to use them or how to check certain things. And I was also able to be a part of the scouting project that we've been doing um, as more of the boots on the ground person, going out and walking in the field and checking for weeds and such while they're running the rest of it on the gator, which you will hear more about that later on in the presentation. And that is it from me.
All right, hello, good morning, everyone. So my name is Thomas McClay. I am the project manager here at Haggerty AgRobotics. I'm currently on the last day of my 16-month co-op here at Haggerty, and I was previously here on a 4-month kind of summer internship, like you'll hear from the guys before, after me. So there's actually been a whole total of 20 months here at Haggerty, and I couldn't be happier about it. So, a little more about me. I've done about 3 years of mechatronics engineering at the University of Western Ontario, going into my last year next week. And I was actually introduced to Haggerty through academic research. At Western, and all the engineers are required to take a writing course in second year. And in this writing course, you unfortunately have to write an essay. And for that essay, you have to pick an engineering problem. And I decided to look into kind of how engineers are trying to help with labor shortages, specifically in the farming sector. And that kind of led me to Haggerty's webpage and see how these robots are helping with that problem. And then I actually found their email and asked them, "Hey, do you guys hire summer students?" And here we are 20 months later. So obviously very happy that that worked out for me the way it did. Very passionate about agriculture and robotics. What's fascinating about agriculture is you never know it all. There's something to learn every single day. Even if two farmers are neighbors, they do things probably completely differently and they each have different opinions on a lot of different things. So there's always something to learn in the farming world. One of the main projects I worked on this summer was the scouting project that Kate mentioned a little for me. Um, I won't go into detail about what that actually means. Ryan later will speak on what we're actually doing with this data and such. But for now, all that you guys need to know is that I was tasked with designing a boom that was roughly 25 feet wide and would house 6 different cameras on it. And not having come from a farming background, and having been tasked with designing a farming implement essentially, I didn't really know what I was doing. So me and my colleague Jason actually went to find some inspiration at a farming junkyard. We thought, hey, if it's been working for decades, might as well take some inspiration from what they've been doing. So we took lots of inspiration, especially from things like hinges and such, to um, to then apply that into our own design for this boom. So here you can see the 3D CAD model of my design on the right there. And then if we go to the next slide, you can see it in real life. So here you can see it with all the cameras attached to it. And it's also currently being attached to the HCW in this photo, but it also has the ability to attach to the front of our gator with a hitch mount here. So that was the scouting project from my perspective. Moving on to the Oz planter. So one of our biggest projects this summer was working with the folks over at the Simcoe Research Station at the University of Guelph. And they wanted to both plant and spray squash. And so to plant, we decided to use the Wizard seeder because it's electric and obviously the Oz doesn't have hydraulics. So we needed to go that route. But I was tasked with mounting the Wizard planter onto the back of the Oz. So to do that, I designed this piece that you can see in the center bottom of your screen here. Now this design required doing some little finite element analysis to ensure that it could hold up to obviously the rigorous nature that is farming, make sure that it could hold up to all those loads. and things of that nature. So that was kind of my role in this part of the Simcoe project. The next more advanced task was designing a whole sprayer to go on top of the Oz. So the goal here was to spray pre-emerge after the squash had been planted. And what's great is the Oz can follow exactly where it had just gone. So we could go right over where we knew that squash had been planted with our sprayer. Um, so my side of designing the sprayer was kind of what you can see at the bottom right. You can see the CAD design for the sprayer. And then on the center of your screen, you can see kind of the plumbing that we had to look into to make this sprayer happen. Um, so this was kind of another learning opportunity because originally a bunch of these pipes that you can see here didn't exist in the design, and that caused a lot of air to get trapped within the bottom of the sprayer design. And after bringing it to the farmer, he kind of showed us, hey, it might be a good idea to add a return line into your drain tank. And that pretty much solved the entire problem. So it worked. It showed us that collaboration is often the best way forward when you're faced with a challenge. Um, Another challenge with this sprayer project was because of the relatively low speed of the Oz, it's got a max speed of about 1.8 kilometers an hour. The amount of spray coming out of the nozzle had to be really relatively low. So in order to achieve that low rate of spray, we had to not only dilute the pre-emerge by about twice its original amount, but we also had to find a pretty specific nozzle to ensure we were again spraying exactly the amount that the farmer had requested. Oh, little glitch there. The last kind of big project I worked on was ensuring that our roboti could fit a planter within it. In order to do that, we kind of did some measurements beforehand, and we realized that the inner width of our roboti was just about 4 inches too short to fit a planter nicely within its center. So we kind of were tasked with widening the robot, and that was kind of up to me. So what I did is I designed these kind of blue and yellow piece that you can see here. So they're 2 inches each, and that created the 4 inch gap that we needed to be able to properly fit that planter in the center. So again, this required some pretty intense finite element analysis again, because as you can see, there's pretty large tanks above here. So that's a pretty heavy load. So in order to ensure that we could withstand such a heavy load, it required some pretty intense stress testing to ensure that the design was capable of holding up to such a rigorous environment. So that was kind of it for the main projects for me. I will then pass you guys along to my colleague Hassan.
Okay. Hey everybody, my name is Hassan. I'm going into my fifth year of computer engineering at the University of Guelph. I'm specializing in embedded systems, and this is my second term at Haggerty, working as a robotic systems engineering intern. Um, I was really drawn to Haggerty because I'm very passionate about implementing robotic principles in agricultural applications. Um, One of my primary responsibilities this summer was working with the Nio TED, which is a vineyard straddling autonomous robot. And a large part of my summer was involved in mapping. So if you refer to the figure at the bottom of the screen, you can see what a map would traditionally look like for one of these robots. The lines in green, those are the actual rows that we've mapped, and the lines in blue represent the custom U-turns that we've made to connect different fields or different blocks of their planting area together. Specifically, our mapping process involved collecting position data with an RTK beacon. And essentially, what happens is every time you collect a point with this beacon, um, the system itself collects a bunch of points at 100 millisecond intervals. This data is then imported and clustered in NIO's proprietary mapping software to actually create the navigational paths. Um, Aside from this, one of the issues that I faced this summer at Case Springs was with our RTK beacon configuration. Specifically, our service provider for the beacon lost network coverage in the area. And to recover from this, we reconfigured the unit from a transmitter to a receiver so that it could connect to the TED's onboard Wi-Fi directly instead of needing additional cell service. Um, Aside from that, also working with the TED, we worked in collaboration with Vivid Machines for data collection. So we would mount the Vivid Machines camera onto the Nio TED and capture images of the Riesling crop at various growth stages throughout TED's operation at Cave Springs. This data that we collected was the input for Vivid's pre-trained AI model, which then generates a yield forecast for the grower. And having this yield forecast provides the grower insights for making better decisions when it comes to harvest logistics and crop management. Um, Moving more to the research and development side, I had the opportunity to work with the rest of the interns this summer on the row mower project. Our primary goal was to interface an automated in-row mower to the Niotad's hydraulic toolbar, which you can see in the video on the left. Essentially, an Arduino microcontroller managed all the motor logic by processing input commands and sending out output signals to the appropriate motor controllers. And just a bit about the hardware, our power was supplied by a 52-volt battery, and we also incorporated a 200 amp manual reset circuit breaker, which acted as our primary safety disconnect. I also had the opportunity this summer to work on my coding skills, specifically in low-level embedded development. Part of my responsibility involved automating sensor data acquisition, and I was able to do this by developing a C++ application to acquire and process data from multiple high bandwidth sensor streams. And in doing so, I learned how to implement a multi-threaded architecture to decouple or kind of separate high-speed data acquisition processes from CPU-intensive tasks like imaging coding. I was also able to optimize the system for zero loss data capture by implementing a dynamic memory queue to manage data flow. All this essentially means is that if you're ever faced with a situation where the rate at which you are acquiring data is significantly faster than the rate at which you can store or save the data somewhere, instead of losing that incoming data altogether, that data fills up a queue in your RAM memory instead and waits there until the processor frees up and then can encode that data stream. I was also sure to implement error handling and performance logging. This we found through field operations was really, really important because a lot of times when systems fail in the field, having a log to go back and see exactly which parameter failed is really helpful in getting the system up and running again. But yeah, with that, I will pass it on to my colleague Ryden.
Bit of a sneak peek there. Hello, everyone. My name is Ryden, and I've been working as a robotic systems engineer intern this term with Haggerty AgRobotics. I'm in my 5th year of computer engineering at the University of Guelph, and my main focus is working at the intersection of robotics, embedded systems, and intelligent automation. I've always been passionate about how robots can be used to solve real world problems. And agriculture is an area I think these technologies could have a very big impact on. That's one of the reasons I was really excited to join Haggerty this term to get some more hands-on experience with advanced robotics. So one of the main implements I worked with this year was the pixel farming laser weeder. It's a piece of technology designed to eliminate weeds without the need for herbicides. The system uses 6 high-powered lasers that shoot a concentrated beam of light that effectively boils the plant from the inside when it hits, effectively killing it. To do this accurately, it uses multiple cameras with a learning model to detect, identify, and locate where weeds are in relation to the crops. One of the features it has is that you can adjust each of the laser's power individually to fine tune it so that you're not overusing your energy. It, it also has the ability to store multiple models on board so that you can switch between them when you need to, so that you're not stuck with any downtime when you need to switch fields. Now, in terms of actually making the model for this laser weeder, To do that, you need about, I'd say, 15 to 30 base images of the weeds in the crop. And then once you have those images, you bring them into the software, manually label them so that when you send them off to learn, it's learning off of what you labeled. And then once they are labeled and you sent it to get the model and you're happy with it, you can always continue to improve the model by getting more images under varying weather conditions, varying light conditions, just to kind of capture all the different things it could run into while in the field. As well, the software allows you to have multiple labels, which makes it possible to distinguish between different crop types as well as different varieties of weeds if you only want to zap certain ones. And then as well, you can see here on the left is a before of running one of the models on just some confetti for a demo. And on the right is the after of the model correctly identifying all the confetti in the picture. As well, I had plenty of time this year to work with the NIO Oz. I was able to work across the different fields of design, testing, maintenance. Specifically for the sprayer, I helped design the back attachment and sprayer hood. As well, I was able to help with testing both the sprayer and the wizard planter in field on a field of squash. This also allowed me to gain a lot of hands-on experience performing maintenance repairs, like replacing the drive shaft, antennas, and other critical components. And beyond that, I also helped support different upgrades, so helping customers install the dual wheels, as you can see there, as well as helping them to reconfigure the GPS beacons due to the 3G network shutting down. And finally, this also allowed me to work directly with a few customers and really kind of help them learn the robot, learn the NIO companion app that comes with it, and how to properly use the tooling and anything they needed with the Oz. Okay, and I was also able to work on this year was the scouting project. This project we're developing with the goal of improving weed monitoring and management in the field. The objective is to provide an accurate weed density map that shows where specific weeds are located and their concentrations. To achieve this, we mounted a multi-camera boom that Thomas had designed and put it on a John Deere Gator and configured the cameras to capture images of the field as we drove up and down the rows. The system focuses on identifying several weeds of interest, such as nightshade, pigweed, horse nettle, and lamb's quarter. And so the whole imaging process works kind of like this, where once we run up and down the rows a few times, we'll bring the raw image data back to our computer, send it through the algorithm for weed detection. And once that's done, we can use that data to plot out the different concentrations and locations of these weeds on a map. And what was interesting this year is that we were able to get these maps while we were on site and physically go out to where these concentrated areas were to visually inspect if it's accurate or not. And this helped us kind of refine the model, figure out what it might be missing, what it might actually be seeing, if there's any confusion or anything we may need to change moving forward. And I think that will wrap up the presentation. So if anyone has any questions, we are free to answer.
Awesome. Thanks so much, everyone. Yeah, as Ryan said, were there any questions for anyone on the Haggerty team?
Yeah, I'm curious about the last one. I'm saying so, by the way. Were you able to train the model to get very accurate weed counts? And if yes, at what stage of the weeds does it start to be accurate?
You're muted.
This is for the last slide, the scouting project there.
Correct, yes.
Yeah, I'd say it's pretty accurate in determining where the clusters are. There's still some issues with making sure it can actually distinguish between the two, but and for crop size, they're still pretty small weeds. Like I'm not sure the correct term, but they're smaller than the crops in this stage.
But you will need true leaves, I guess, not on the cultivating stage. I don't know if you're familiar with those terms, but basically the first two kind of heart shape or leaves, or you need like actually larger, more developed leaves to be able to identify the weed?
The bigger ones are more what it's kind
Okay,
of for.
true leaves. Okay. Still very impressive. Thank you. I know you'll get there.
Thanks, Caesar. We had a question in the chat. Great work. I let my son sit in on the presentations. Did you use a software for training on the laser slash confetti?
Yeah, so the Laser Weezer, the company there, has a website for where they host their software and all that. And you use that website to upload all your photos to, do all the weed identification and labeling. And then once you have all your labeled photos, you just hit a button to generate a model and you can configure the different, like the confidence rating, um, and then what labels you want it to actually identify as a weed and which ones you want it to just say as a plant. And then it's as simple as just selecting the photos you want to train it on, hitting a button, and then waiting 10 or waiting 15 minutes to an hour, depending on how long it takes for the model to train.
Great, thank you.
And then Alyssa didn't have a question, but just said as someone who works in the Waterloo Co-op department, great presentation. Always wonderful to see the brilliant ways students from all schools bring value to companies while getting great work term experiences.
Thank you.
Thank you.
Awesome. Any other questions for anyone on the team?
If there is time, I want to ask one more. Are we
Absolutely.
good?
Yeah, absolutely.
Yeah. Okay. Yeah. So following up with the previous one of related to weed identification at a very early stage, these laser systems are more effective when the weeds are very small, but at the same time, that's when they're harder to identify to separate from the crop. You, have you found that challenging then?
I found it.
Identify weeds and hit them at the right stage at the same time when they're like,
For certain, it kind of depends on the weed type. For more like the standard smaller like pigweed and stuff like that, it does pretty well at identifying where they are with their distinct shape when they're smaller. Where things it kind of struggles is more with grass and weeds like that because it's just such a wide area, and if the laser doesn't hit the right spot, it might not fully kill the grass. But in terms of labeling them, it does a pretty good job.
Well, I
that's
think
it.
can I just add a comment on this too? I think one of the things too is that we're trying to do this at high speed, right? We're not trying to we're trying, in the case of processing vegetables, the market demand is lots of acres per day, versus exactly like millimeter precision as to where those weeds are. And that presents its own challenges. If let's say we want to try to get one machine that can cover 300 or 400 acres in a day, so the weeds have to have a certain size just to be able to see that. And in that production system, this is the model that has been recommended to us.
Excellent. Thanks, Chuck. Michael in the chat was wondering who would be best to contact at Haggerty to discuss possible future internships.
You could do exactly what I did. Email the support email that's on the webpage there. I believe it's on the About Us tab. Yeah, About Us
Or
tab.
contact, the contact.
Contact. Yeah.
That's also what I did, and it worked great. So highly recommend.
Just reach out, and I see Chuck added the email address into the chat there. So thanks for that, Chuck. Excellent. All right. Well, hope you had a great summer. Thanks so much for taking the time to give us that presentation and summary. It was pretty good. Looks like you got a lot of good experience done this summer. So congratulations.
Thank you
Thank
very
you so
much.
much.
Thank you.
Sorry, just got a phone call. Don't know if that came through. Um, Excellent, perfect. Sorry, distracted me. We'll move on through the agenda for the morning. No project updates this week. So we'll just move forward into the roundtable discussion. So we have our prompts there for ag robotics and ag tech companies. What were some successes or challenges you might have experienced this week? Or producers industry, did you encounter any problems that you wish a robot could have solved? And then, of course, we are not limited to those discussion topics, just to sort of get the ball rolling on things. Chuck, go ahead.
Just a couple of updates. I had the opportunity to watch Bear Claw Robotics Weeder in action this week, and um, two reps from OMAFRA were there as well. It was very nice to see that weeder working. And then we had a very successful demo event. I think it was successful at the Great Tailgate Tour. It was very well attended, which I think was surprising. I think it worked out well that the growers weren't as busy, and some hats off to Hassan and the team, because in the previous years when we had the TED robot up at Cave Spring running, we would let it run one or two. Wendy's retiring. It could very well be Kristen. And the in the past, we let the TED robot run one or two fairly simple up and down the vineyard, while the audience was in attendance. This year, Hassan let it run a significant amount of acres during the presentation. And I think the people watching it were very surprised that we were just letting this machine work in the vineyard unattended while we were just having a conversation about the robot. And so it really speaks to how autonomous these machines can actually be and work. So that was, I guess, my highlight of the week.
Awesome. Thanks, Chuck. Glad to hear that. Sorry, apologies. I keep getting phone calls. And my computer is my phone, so there's not much I can do about that there. Yeah, great. Glad to hear that it went well and you were able to just let the TED do its thing. That's awesome. Uh, any other thoughts, comments, questions? Anybody? No? Everybody just wants to get it over with, get to the long weekend.
I'm gonna say I'm
Um,
looking forward to the berry grower event next week. Um, Conrad, I do owe you a phone call, so that will happen here at some point today.
I was just wondering about that actually. Good, excellent. Actually, do we have any numbers for is anybody from the working group joining us as well on Thursday next week? Because we need the numbers for there's a dinner being served as well, and we just need some numbers to confirm.
Long
uh,
weekend and
I know Bridget and I will be there.
Okay. Can you submit numbers by noon today also? Let us know who's coming. It'll be good. Just to plan. BGO needs to know the numbers so we can actually get this all organized and everything. Just for anybody who's not aware, we are having a showcase in a strawberry farm on Thursday, 4 p.m. It's going to be probably going till about 7. Who wants to stay later and see it running at nighttime can actually stay longer. It's supposed to be a nighttime application, so it's going to be normally in operation, you would run at nighttime when it's dark. We will be running it at 4:30-ish kind of a thing once everybody arrives, just to do a demo for everybody. But then we will, after dinner, we'll also go back out again and give an opportunity for anybody else to see it when it gets darker. And Chuck is going to be there as well with his group. They're going to show some of their robots as well at the same time. So there's going to be a strawberry UVC application, what we're going to be seeing there. It's mostly for berry growers in this case. But we'll be showcasing our AgRobotics robotics platform, which is basically an above ground, anything that's not in the ground, anything that's above ground, that's what we would like to handle with our robot. That's kind of the applications that we're focusing on our side. So yeah, hopefully many will come, and looking forward to seeing you all out there.
Perfect. Thanks for the details and update on that, Conrad. Appreciate it.
Yeah, thank you.
Alyssa.
Yes, hi, thank you. I did put in the chat, I'm here with University of Waterloo Co-op. That is not why I'm coming on camera to talk right now. I just have a really interesting event to share on behalf of our Office of Research. So thank you for including it in the agenda. There's a link there, but because it's quite a unique event, I just wanted to take a really quick moment just to mention it. So it's called an AIM Day, so Academic Industry Meeting Day. Our Office of Research is hosting in October. These are a unique type of event that universities all over the world do. It was created out of Uppsala University in Sweden, where industries can connect and brainstorm challenges and solutions with researchers in a roundtable format. So the theme for this one is AgTech North. So it focuses on automation, AI, digitization, logistics, other technologies for sustainable agriculture in northern climates. So I will put a link in the chat just when I'm done talking, or else I'll get all mixed up with myself, and a brochure as well. But I just wanted to flag it in case anyone would be interested in submitting one of those questions or challenges. So companies, there's no cost to do it. So you can submit, it could be a very technical solution you're looking for, an idea, like a broader scale one. And the idea is organizations submit questions, and then our faculty members sign up to do the 1 hour roundtables to discuss each one. It's all in person on campus. They're really, really interesting events. Often you get great ideas out of it. And the idea is maybe even funded research projects could come out of it. And the research team, that's the contact that will be on the website and the brochure, they help with all that. So I used to work in that office. I can answer a few questions, but they're really the experts. So I'm just going to put a little bit of information in the chat, but for anyone that may be interested, I'd encourage you to check it out. There's no registration link. It is meant for like booking a meeting to talk through what types of questions may make sense. They can help you formulate all that. But we get some really cool things coming out of these AIM days. It's our 4th or 5th one I think we've done on campus. So just wanted to share with this group because of the topic. So thank you so much.
Perfect. Thanks so much, Alyssa. Appreciate the extra details on that. Caesar, please go ahead.
Yeah, so yesterday I was touring some tree nursery farms, and they are very interested on looking into weeding technology, specifically laser. It doesn't have to be laser, but I think it's a good application for it. When they start, these trees are like very small seedlings, very high density, high value, and they don't have very good chemical tools to deal with the weeds. And basically they do it by hand. And if you see those fields, they're like thousands of fields per square meter, and they need to pull them one by hand. And they're very curious about this, but they don't know where to start with it. So I think it would be very helpful if we can connect with them. They're also a sector that is very open to innovation. So I think it's kind of like a perfect match, and I encourage you, if any of you want to connect with me later, and I can help you organize something with that group.
Perfect. Thanks, Caesar. Maybe if you wouldn't mind just quickly throwing your email address in the chat there, so folks can reach out if they are interested.
Oh, good. Thank you.
Awesome. I saw just in the chat there, Kristen from MAFA. They're currently partnering with Rainbow Greenhouses to find their next vice president of operations. So there's some details in the chat there, a couple of links if that sounds like something you're interested in, and I can add that to our job board as well on our website. Kyle, go ahead.
Yeah, just a quick comment. First, with Alyssa on those AIM days, super interesting. I was just curious if there's any like outputs from that process, because that would be interesting to see. I don't think it's something that I could attend, unfortunately, because of where I'm located. But beyond that, and I just wanted to just remind everybody about the GC Expo that's hosted at Area XO. You guys were there last year, I believe. Haggerty was, or this working group. I was just kind of curious, or assuming that you're going to be there this year. We're in the midst of trying to organize a booth for AFC from our programs branch to be there. So anyway, just wanted to raise that. I think that's like the 15th or something. I can't remember what day it is, but of September.
It is September 24th.
Yes, September 24th. There you go.
I'll see you there. Come.
Perfect. And thanks for that reminder. I'll make sure it gets added onto the agenda there. Excellent. Not seeing any other questions in the chat. Was there anybody else anything to go over? I know we did have a new opportunity that showed up in the for funding announcements and opportunities, the AgSys 2025 program. I was sent a link for it earlier this week. Applications close for it on the 31st of August. So there's not much time left there if that's something that you're interested in, but the link is in the agenda there if you are. Bridget, go ahead.
We talked about it a little bit last week, but just to mention that we will have a booth at the Outdoor Farm Show as well coming up in September. So if you are attending that show, please stop by and say hi. Joe with RHA, Chuck's team, as well as Dan and myself will be there. So we'll be in the OMAFA Innovations tent. And I did also just double check because we had talked about the Ag Tech breakfast that they're hosting on September 10th, but I don't see a registration link yet for that. So once we see that, we will post it out to everybody.
I think it goes live today. I think it was the 29th. So if you go to the Outdoor Farm Show website and click on the special events and then look for the Ag Tech breakfast, it's free. Anybody on this call should show up there. It's a great networking opportunity with all the innovative companies, plus investors, plus all the other stakeholders. So encourage everybody to show for that.
Awesome. Thanks, Joe. I just threw the website in the chat. They don't have the link up yet, but we'll keep an eye on it for later today.
Perfect. Thanks for the update. Ainsley, go ahead.
Hi, I just was going to ask Conrad for that event coming up. Would you be able to put that in the chat, the details? I'm not sure I can make it, but I might want to pass it along to some colleagues here in our regional office who might be interested in attending.
Yeah, absolutely. Of course, we'll do. Yeah.
Okay, thank you.
Well, another thing that got an email this week from Real Life Robotics in Waterloo. They're having a networking golf invitational on September 19th. So if you're interested in going to that in Waterloo, I suggest just reaching out to Real Life Robotics or find them on LinkedIn. I think they posted it there as well. So a few networking opportunities for people.
Excellent. Always good to hear about those.
And then I don't know, did you see Chuck, John Deere acquired Gus?
Yeah, I did. Yep.
Automation this week. So another robotics company is acquired by John Deere. So
if people are unfamiliar with Gus, they are essentially a stainless steel tank on wheels for spraying orchards and built and designed out of California. And they've been around for about 5 years, I think. Very well built machine, very robust and extraordinarily simple machine. There's not a lot of complicated tech on it other than it can drive itself around. So
excellent. Thanks for the update. We've still got about 13 minutes left. If there's anything that anybody wants to take an opportunity to speak on? If not, we can cut it early. Start our long weekends a little bit earlier.
I just posted one more event coming up in the chat if you want to take a look.
Perfect. Thanks, Kristen. Join us in celebrating the launch of the new Conestoga Biotechnology Research and Innovation Hub on Wednesday, September 24th, 3:30 to 5 in Kitchener. Enjoy refreshments, networking, remarks, and guided tours of the labs. Please RSVP by Friday, September the 19th, using the link below. And there's the link in that message there as well. I'll make sure I add that onto the agenda for next week as well, just so it can remind some people. And then just another reminder there, or some details for the Twilight meeting on September 4th. You can email Conrad, myself, or Bridget for some details on that. All right. Well, thanks everybody. I think I think it seems like we're at the end for this week. But that's all right. It is just before the long weekend, so no worries there. Thanks again to everyone from Haggerty for taking the time to present. We really appreciate the updates and seeing how the season goes there. Everybody, thank you for your updates and your questions. Have yourselves a great long weekend, and we will see you back on September the 5th.
Thank
All
you.
right. Thanks, everybody.
Bye,
Take care.
Before we go, can you just post that 31st funding opportunity into the chat? I don't, in case I can't find it in the agenda.
Yes, I will post that right now.
Great, thank you.
You're very welcome. All right, take care, everybody.